If you remember back at the beginning of the year, we talked about radicals, right? Radicals are root signs. Remember that this number is the number that goes in there is the index. If there's nothing there, it's a square root, which means there's a 2 there. And we've already evaluated these and talked about them. We're going to talk a little bit more about them today. So I know we know the answer to this, but right, the square root of 14 is 4. And the reason why I know that is because 2 squared equals 4. Right? A radical is the inverse of a power. If I come down here, the cube root of 64. So the question I'd ask myself is, what to the third power equals 64? If you're not sure, just try some numbers. 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. Well, that means the cube root of 64 is 4, right? They're inverses. They just work backwards from each other. Pause the video, and I want you to work through the rest of these and see if you can find out what they are equal to. So square root of 81 is 9, because 9 squared is 81. Square root of 25 is 5. Hey, square root of 48. That one is not a perfect square. Perfect squares are numbers that you can take the square root of and they come out evenly. I can figure out though, right? I know that 48 is between 36 and 49, and I know the square root of 36 is 6. The square root of 49 is 7. So it has to be somewhere between 6 and 7. If you plug it in a calculator, I'm pretty sure it's like 6.9 something. Square root of negative 64. So you're asking yourself, what do I square to get negative 64? The answer is there's not a real number, right? If I square negative 8, that's a positive. If I square a positive, it's a positive. So since you can't square a number and get a real number and get a negative, that means that this is not a real number. Cube root of 8, 2 to the third equals 8, so the cube root of 8 is 2. Hey, negative 8. Now this is different. If I take negative 2 cubed, right, negative 2 times negative 2 times negative 2, that would give me 4, times by that would give me negative 8. So you can cube a number and get a negative 8. So we don't have the same problem as we did up here with the square root. So the cube root of negative 8 is just negative 2. 4 through to 16. You're asking yourself, what to the fourth power equals 16? And it ends up being 2. 2 times 2 times 2 times 2. So 2 to the fourth is 16. So we know how to evaluate these. What we're going to focus on today is when you have numbers like the square root of 48 that are not perfect squares. It turns out that if they're not perfect squares, they end up being irrational numbers. And if you think back to what irrational numbers are, that means that they're not rational. Rational numbers are numbers that can be written as a fraction. So they include whole numbers, they include fractions, they include a lot of decimals. As long as the decimals stop, they terminate, or they have a repeating pattern, then you can write them as a fraction. There are some numbers like pi, where the decimal goes on forever and there's no repeating pattern. That means there is no fraction that equals pi. So it turns out that square roots or radicals that are not perfect squares, that don't come out evenly, are also irrational. So if I plug that in a calculator, it's let me grab that here. Square root of 48 comes out to be 6.9282, and it just keeps going. So it's an irrational number. What we're going to focus on today is taking a number like the square root of 48, and even though I cannot write the decimal equivalent because the decimal goes on forever, I could write an approximate, but it wouldn't be exact. So instead I'm going to take the square root of 48 and just simplify it, and I'll show you how to do that. When I think of this, I kind of think of fractions, right? If I give you 4/12 and ask you to simplify that, you divide them both by 4, you end up with 1/3. Right, those are equivalent, they're the same thing. We're going to do the same thing with square roots. So we're going to take square root of 48 and just write it in its simplest form. So one method of doing this is you can take 48 and find all of its prime factors. So I know 48 is, 4 times 12. 4 is 2 and 2. 12 is 3 and 4. You guys have done this before. It may have been a long time, but we found all their prime factors. So I know 48 is 2 times 2 times 3 times 2 times 2. The reason why I did that is because I can take this up and write it as being 2 squared times 2 squared times 3. And now I can simplify this. I kind of got ahead of myself though. Sorry, got excited. Before I finish this off, I want to show you something. So we'll come back up to this in a second. Just look at this problem right here, these two examples right here, or these 4 examples. I want you to compare these two right here. So I got the square root of 9 times 4. 9 times 4 is 36. Square root of 36 is 6. Now let's try it this way. Let's take a square root of 9 and the square root of 4 separate. So the square root of 9 is 3, and the square root of 4 is 2, and you end up with 6. So it doesn't matter if I take the square root and multiply my two factors together, or I can actually split them apart as 2 separate radicals and do it that way. Let's see if it works with addition. See, square root of 9 is 3, square root of 4 is 2. That's 5. This one would be the square root of 9 plus 4 is 13. Square root of 13 is irrational. It doesn't come out evenly. What, it's going to be 3 point something? It's definitely not 5, though. So these two are not equal to each other. Up here, these two are equal to each other. So we've got this property in math where I have a radical. If I have the square root of a times b, I can split it apart, get the square root of a times the square root of b. And we can go either direction. I can go from this to this, or from this to this. It turns out that works with fractions also. So make sure you have these two properties written down here. So I can do square root of a over b, or a divided by b. I can split it up. I can go square root of a over the square root of b. Addition and subtraction, that does not work. So if I have the square root of a plus or minus b, this is not the same thing. I cannot just split it apart. So it works with multiplication and division. It does not work with addition or subtraction. So the reason why that's helpful, if I come back up here, these are multiplied together. Well, we just said we can split those apart. So I'm going to split them apart. Square root of 2 squared. Well, a square root and a square just cancel out. That's 2, right? 2 squared is 4, square root of 4 is 2. Same thing there. This comes out to be 2. Square root of 3 I cannot do anything with. It's an irrational number. 2 times 2 is 4. So the square root of 48 is the same thing. They're equivalent to 4 square roots of 3. 4 square roots of 3, though, is simplified. It allows us to, and that's going to help us. You'll see when we go to solve quadratic equations that sometimes the solutions come out to be irrational. And we can simplify answers down if we can simplify these radicals. So that's one reason we want to be able to do it. Okay, that's what we're focused on. The first part of the lesson is just simplifying radicals. So let's go through and do a couple of these. Let's do number 2. Now we said if I had the square root of negative 80, that would not be it's not a real number because you cannot take the square root of a negative. This is different though. That negative is on the outside, so I can just ignore it. And I'm just going to focus on the 80. I do the square root of 80 first before I add the negative. So let's do that. I'm going to take 80, 8 and 10, 2 and 4. Sorry, let me do that again. 10 is 2 and 5. 4 is 2 and 2. So I've got all my prime factors. Look for those pairs. I've got a pair of 2's and a pair of 2's and a 5. Whenever you have a pair of factors, those are the ones you can simplify. So I've got 2 squared, and 5. I can split those apart. That's 2. That's 2. And that's a square root of 5. Negative 2 times 2 is negative 4. That is a negative square root of 80 in simplified form. So you're always looking for these pairs of factors. If you don't have a pair of factors, then you can't simplify it. Let's try 4. So let's do 4 together, then I'll have you guys try 1 and 3. So when you have 75, now I have a variable, just do the number first. So start with the 75. That's 3 and 25. 25 is 5 and 5. So I've got a pair of factors. And I've got that 3 that doesn't have a pair. Okay, square root of 5 squared is 5. and I've got the square root of 3. But I still need to work with that n to the 5th. When you think of n to the 5th, it's really just like, it really is just having 5 n's. So if I look at it, I've got a pair. So I've got you can think of it, let me do this off to the side, square root of n squared times the square root of n squared times the square root of n. Well, that gives you an n, and that gives you an n. So on the outside, we're going to have n squared. Then I have this one left over. It goes on the inside. So you can break a variable apart just like we did with the numbers. Okay, I want you to pause the video. Go ahead and work through number 1 and 3. Simplify those, and then come back and I'll show you the answers and you can check it. 24, right? 24 is 3 times 8, 2 times 4. So I've got a pair of 2's. So I've got the square root of 2 squared times by, and the other two don't have pairs, the 3 and the 2. I'm just going to put them back together. So that comes out to be 2, square root of 2 squared. This is going to be the square root of 2 times 3, which is 6. So if you have more than one factor left over that doesn't have a pair, we got these two right here. We've got the 3 and the 2. Okay, just combine them back together to get that inside number. Hey, 49. Square root of 49 is just 7. But I need to break apart those x's. So I'm looking for those pairs of factors. That gives you an x on the outside. Then I've got that x left over. It stays on the inside. Okay, there's our simplified form. Okay, so that's simplifying radicals. We're also going to add, divide, and multiply radicals also. So let's do addition or subtraction. In order to add or subtract radicals, they have to be, I like to call these like radicals. Okay, and what I mean by that is the square roots or cube roots have to be exactly the same. So this, right, 3 squared of minus 3 squared of 5 and minus 2 squared of 5, they're both square roots of 5. I consider those to be like radicals. And what I'm thinking of, think of this problem. This is different. This is with variables, but if I have like 2y minus 3x minus 2x, think about which ones are like terms there. Well, the 3x minus 3x and the minus 2x are like terms. So the 2y would stay the same, but I can combine those two. Minus 3 minus 2 is minus 5. This is just like that. So compare that over here. So this one over here is different, right? It's a square root of 3. But both of these are square roots of 5. I can combine those. So the 2 square root of 3 is going to stay the same. But when I combine these, I combine the coefficients. So that means I take the numbers in front, just like I did over here at the negative 3 minus 2. I go negative 3 minus 2 is a negative 5 square root of 5. Okay. So these two right there combine to give me that. The radical stays the same. The square root of 5 does not change. You just add or subtract the numbers in front. And that's really as far as we can go with that problem. Here's another one. I got negative square root of 3 minus 3 square root of 12 minus 3 square root of 3. So if I look right now, this and this are like radicals. They both are square roots of 3. This has a negative, this has a 1 in front. So I got negative 1 minus 3 is negative 4 square root of 3. Now, a lot of times think, hey, we're done. Here's something to be careful with is you got to make sure the radicals don't simplify. Square root of 3 does not simplify. I can't break 3 apart. But 12 breaks apart to be 3 and 4. 4 is 2 and 2. I've got a pair of 2's right there. So I got negative 4 square root of 3 minus 3 times square root of 2 squared is 2. That would times those together, that's 6. So I end up with negative 4 square root of 3 minus 6 square roots of 3. So once I simplified that square root of 12 right there, I ended up with another square root of 3. So now I can keep going. These are now like radicals. Minus 4 minus 6 is minus 10. So minus 10 square roots of 3, and there's my answer. So you've got to make sure these radicals, like right here, right? Got to make sure these radicals are simplified. That square root of 12 simplified down further. You got to recognize that. You guys try this one. Give this one a try, and then pause the video, try it, and then come back and we'll go through it. So 2 square root of 6 and 2 square root of 6, I can add those together. That's 4 square root of 6 Square root of 24, we're going to try simplifying that. So take 24. 6 doesn't simplify, right? It's 2 and 3. 24 does. It's 4 and 6, 2 and 2, 2 and 3. I've got a pair of 2's, so it'd be the square root of 2 squared times the square root of, and these two don't, so I'm going to put them back inside and end up being a 6. So I end up with 3 times 2 square root of 6. Well, that would be 4 square root of 6 plus 6 square root of 6. They're both square roots of 6. Add them together. We got our answer. Okay, let's do division real fast. So we said earlier that if I have the square root of a over b, just like multiplication is you can do them separately. You can do the square root of a over the square root of b. So down here, right, if I have the square root of 23 over 9, I can write that as being the square root of 23 over the square root of 9. Square root of 9 is 3. So square root of 23 over 3. Okay, there's my answer. Square root of 23 can't be simplified, right? It doesn't break apart. There's no factors that come out. This one, the negative doesn't matter because it's on the outside. It'd be the square root of 17 over the square root of 100. Well, I can simplify the square root of 100. So I end up getting negative square root of 17 over 10. You guys do 8 real fast. Pause it, do 8, see what you get. So it'd be the square root of 4x squared over the square root of 64. Square root of 4x squared is 2x. Square root of 64 is 8. There's our simplified form. Okay, I'm going to skip past the rest of those. Well, let's actually do this cube root. It's kind of interesting. If you have a cube root, I don't want to look for pairs of factors. I want to look for triples. And what I mean by that is 54 is 6 times 9. 9 is 2 and 3. Sorry, 6 is 2 and 3. 9 is 3 and 3. I've got those 3 3's right there. That wouldn't help me with the square root, but now with the cube root it does, because I can go like this. The cube root of 3 cubed times by the cube root of 2. Hey, the cube root of 3 cubed, they cancel out. A cube root and a cube are inverses. That's just 3. So when you're looking to simplify a cube root, instead of looking for pairs of factors, I want to look for those triples as I go down through and simplify that. Okay, the last thing is rationalizing the denominator. So when you have, like, rationalize means to make rational, and denominator means the bottom of the fraction. It turns out, and this kind of is a real quick story, this is kind of interesting. Back in the day before they had calculators, we had handheld calculators just sitting in front of us. They used to have these tables because, if I had like the square root of 2, I'd have to look on the table and find out what the square root of 2 was because I didn't have a calculator to use. It's a decimal, right? That decimal goes on forever. It's irrational. So they would write down an approximation to it. It's really hard to take 5 and divide it by a decimal. So they started this thing where you don't leave a square root in the bottom of the fraction. It's easier to times or divide a decimal by a whole number than it is to divide a whole number by a decimal. So what they did is they took the denominator, and if it was not rational, like square root of 2 is irrational, they would change it so the bottom was rational. And this is how they do it. It's not hard. If I have 5 with the square root of 2, I just take the square root of 2 and times it by the square root of 2 on the top and the bottom. So I end up with 5 square root of 2 on top, square root of 2 times the square root of 2. Well, that's a square root of 2 squared, which we've already said that they just cancel out. So it ends up being 5 square root of 2 over 2. If you take this and plug it in the calculator, it's exactly the same thing. This doesn't even look simplified, right? Really, honestly, it looks even probably more complicated than this. But I did rationalize the denominator. That means, look at the denominator. It was a square root of 2, which is irrational. Now it's 2, which is rational. So this process of rationalizing the denominators kind of became a habit. Is it really necessary now with the calculators we have now? Now, probably not. But it's still the way, if you want to be a polite, proper mathematician, it's still the way that these problems are written. Okay, let's do one more together. Let's say I have 6 over square root of 8. Well, I don't want the square root of 8 down there, so I'm going to times by the square root of 8. I get 6 square root of 8 over 8. Make sure your fractions are reduced. The 6 and the 8 are outside the square root, so I can simplify those. If I divide them both by 2, I'd end up with 3 square root of 8 over 8. or sorry, over 4, right? I just reduced the 6 over 8. Now make sure your radical simplified. Square root of 8 breaks apart. That's 2 and 4, 2 and 2. So I got a pair of 2's. That'd give me a 2 on the outside. So I end up with 3 times 2 times the square root of 2 over 4. Well, now I could simplify that even further. So my final answer is 3 square root of 2 over 2. These do not simplify because the 2's inside the square root, this 2's on the outside. If I wanted to at the beginning, I could have simplified that square root of 8. That would have been fine, but you get the same answer either way. When you go to rationalize the denominator, there's another type of problem. Oh, here's some right here. Let's just try a couple of these before I do the other one. So you guys try, why don't you pause it and try 1 over the square root of 5. So to rationalize, I just times the square root of 5 by itself. So on top, I get 1 times the square root of 5 is the square root of 5. On the bottom, square root of 5 times the square root of 5 is the square root of 5 squared, which is just 5. That's really as far as I can go. 14, I got square root of 10 over the square root of 3. Again, I want to get rid of that square root over the 3, so I times it by itself. On top, I get square root of 30. On the bottom, I get square root of 3 times the square root of 3, which is 3. I got to check to see if 30 simplifies. 30 is 5 and 6, 2 and 3. There are no repeated factors, so I can't simplify it. I want you to look at these bottom couple of examples. This is the second type of problem. So look at 18. We have 8 over 1 plus the square root of 3. Don't write this down, just watch. A lot of times I see people tie to times by the square root of 3. Whoops, that's supposed to be a 3 on the top and the bottom. The problem with that is if I times through, that does give me 3 there, but when I times through there, I end up with this, square root of 3 plus 3. Well, I still have a square root on the bottom. So this is a little trick. If you're trying to rationalize the denominator, and you have 1 plus something, if you have a plus or a minus in there, then you need to times by its conjugate. Its conjugate is this. So if I have 1 plus the square root of 3, I'm going to times it by 1 minus the square root of 3. So the conjugate, you have the same two terms, 1 and the square root of 3, but one has a plus and one has a minus. If I times the bottom of the fraction by that, I have to times the top. Okay, now I'm just going to multiply this out. That would be 8 minus 8 square root of 3. Okay, on the bottom, this would be 1 minus square root of 3 plus the square root of 3 minus square root of 3 times the square root of 3, which is 3. Well, what will happen when you times by the conjugate is those middle terms that have the square roots will cancel out. So now I have 8 minus 8 square root of 3 all over 1 minus 3. 1 minus 3 is negative 2. We can keep simplifying. So now divided by negative 2. 8 divided by negative 2 is negative 4. Negative 8 divided by negative 2 is a positive 4. There we've got to simplify down all the way. A little tricky. You guys try 20 really quick. So remember, times by its conjugate. So pause the video, try it, then we'll do it together. All right, so the conjugate, a square root of 2 plus the square root of 7 is a square root of 2 minus the square root of 7. So on top, I get 12 square roots of 2 minus 12 square roots of 7. On the bottom, I get 2 minus the square root of 14 plus the square root of 14 minus 7. Well, those two middle ones cancel out. That's what we wanted. So I have 12 minus 12. Sorry, let me just do that again. It's 12 square roots of 2. 12 square roots of 2 minus 12 square roots of 7 over. And then on the bottom, I end up with 2 minus 7, which is negative 5. You can't divide 12 by negative 5. So we can, and square root of 2 doesn't simplify. Square root of 7 doesn't simplify. So that's really as far as we can go. You could write the answer this way, just in case you might see this. If you have a negative on the bottom, I could actually times top and the bottom by a negative. So the top would flip signs. So flip those two signs, and then the bottom would change to a positive. These two answers are the same. So if I saw, if I was doing a multiple choice test or something, I'd be happy with either of those two. Really the only thing left we have is multiplying. We just did it up above, but when you multiply, just remember Let's do this one problem. I don't know, something like this. You're just going to multiply like you normally do. So that's 2. When you multiply anything on where you have one thing on the outside and one thing on the inside, you cannot multiply the outside anything on the outside to 2 by anything on the inside, which is the square root of 2. So you just 2 times the square root of 2 is just 2 square root of 2. Now I've got 3 square root of 5 times 1. And then I got 3 square root of 5 times a negative square root of 2. Now, square root of 5 and square root of 2, they're both on the inside. You can multiply those. So it'd be minus 3 square root of 10. And 5 times 2 is 10. Okay, so simplifying radicals. You got to be able to simplify just a single radical, like we did at the beginning. You want to be able to add or subtract radicals. And we want to be able to divide. And when we're dividing radicals, you're really doing this process of rationalizing the denominator. So rationalizing the denominator, dividing is what we're doing there. And the last thing is multiplying. I think that's it, though. Good luck with that.